This is Cup of Go for February 13, 2023. Stay in touch with the Go community in just 15 minutes per week. I'm your host, Jonathan Hall.
And I'm your co-host, Shai Nechmad.
How are you, Shai?
It's cold, but it's only me being cold. But I have my cup of coffee here, so I think we can dive into the news. And boy, do we have a lot of stuff to talk about this week.
We sure do.
All right, so let's start with the basics, expected releases.
Yeah.
So tomorrow, as a gift for Valentine's Day, the Go team, other than chocolates, is giving us two new versions. 1.20.1, which is the first patch for the new version, and 1.19.6. But I guess we'll find out tomorrow what these releases include.
Yeah.
Also tomorrow, two new versions of libraries are being released, Ximage and Ximage TIFF. These are basically security fixes. So we don't know what the security vulnerability is there yet, but tomorrow it will be fixed. So if you haven't exploited it already and hacked into the mainframe, then it's going to be too late. So these are the new releases. Let's talk about proposals. And boy, this week do we have a proposal to talk about.
We sure do. There's been some drama. So there's been a proposal put forward by Russ Cox to add some telemetry to the Go toolchain. And he's written a very thoughtful and detailed proposal and a few blog posts explaining the proposal. But the TLDR is the Go team would like to know some of the less exciting features of Go, if they're actually being used and need to be supported. And in the blog posts, which of course we'll have links to in the description, he goes through some examples where this would have been useful. And he gives an example of one. I think it was in 1.18 that they had decided to deprecate, and then during beta testing discovered that a lot of people were actually using it. So this is an example where this telemetry would help. Now, there's been drama because, of course, whenever you start adding telemetry to tools people use, alarm bells start to go off everywhere, right? His blog post does a really good job of explaining the potential privacy implications, and that no personally identifiable information, not even IP addresses or MAC addresses, any of that stuff is going to be tracked. But of course, people are still concerned. So that's the reason for the drama.
Now, looking at the discussion, the moment Russ put this out, there were, I think, like 500 comments, and then the thread was locked.
Yeah.
But I would say that there are a few, like you can bucket the responses, at least the respectful ones, to a few types of support, or some questions or disdain for this proposal.
Mm-hmm.
The first group is people who think this is good. The way the team presented this is talking a lot about the telemetry being very transparent. This is they go into it pretty deep, but it should be anonymous. And people who support this say this is a tool we all use. This information seems harmless. Making it better is relevant. And the reason the team wants telemetry is because their current information sources of basically bug reports, surveys, and perhaps independent research on open source projects is not enough. In one of the common threads, Ross goes into detail about the difference between open source software, which tends to be smaller and has very different use cases, than closed source enterprise software. So the telemetry from both would give them a better image. And I would say that right now, at least in the thread, these comments are the minority.
Mm-hmm.
Most people do not agree with this proposal.
I haven't had time to read all 394 comments that were done on 394 replies plus 95 comments. So yeah, it's a lot to read. A lot of it looks to me like kind of knee-jerk reactions, like don't track me, without actually having read the details about, this isn't tracking personal data. And I understand some people still don't want that tracking. But the biggest controversy is the idea of making it on by default versus off by default.
Yeah, people prefer opt-in for
right.
stuff that's related to privacy other than opt-out.
And I completely get that, and I would be on that side of the fence too if it weren't for the fact that if it's opt-in, it very likely will not produce valuable data in that case.
And there is, I think, an underlying current in the knee-jerk reactions that are negative of that this is something that's already been decided, developed, and this discussion is just a rubber stamp, which I personally don't believe is the case at all. I assume that the reason that Russ and the group wanted the public discussion is because they know that they need to get the Vox Populi before they just push something like that into the toolchain.
Right.
Just to clarify, the telemetry is not being sent from the compiled Go production services. It's being sent from Go build or Go run.
Right. And also to emphasize that the data is anonymized, and the proposal is to make it completely openly accessible, so anybody can go see the telemetry data that's collected. It's not just private data that only Google has access to or whatever. So they're trying to. I mean, I think they're making a good effort to be as open about it as possible, but it's still a steep hill to climb.
Yeah, the way they frame it is they call it transparent telemetry, which is running a collection server, sending configurations, and, telemetry should be very anonymized, doesn't include an IP and whatever. And I think the majority of the comments are against this proposal right now. So it would be and now it's locked. So I'm not sure, there's other discussions raging on in Reddit and Slack. So
and
if
here
you
now,
want to talk about it, you can definitely find a place to cast your voice and your vote. But this definitely seems like a very, very interesting moment. Of course, we'll try to stay on top of it.
Yeah.
So what other proposals can we talk about? Perhaps some that have been accepted.
Yeah, that's a great point. Do you want to talk about the new context proposal? That one looks kind of interesting to me.
So, there's a very simple use case, which I hope won't be abused, but I pretty much assume will be abused. And then it will lead to a whole new class of bugs where you can pass a context without cancel. Now, some of you might be scratching your head and saying, why would I need an uncancelable context? So basically the point is, let's say I have a cancelable context in an HTTP server, and then I finished responding. Now I have to do some cleanup, update the database, send some logs, update some metrics, etc., etc. I still want to use the context because it has the user ID and their token and what's their role and what's their access and whatever. Trace ID, I don't know. It has info, but I don't want to be canceled because I want to finish all the cleanup tasks. So what you can do is you can take the original context and do without cancel. Now it's uncancelable. Seems very useful. What I'm worried about, I don't know if you share this concern, is that when you see a function, let's say you see in the signature that it returns an error, right? Then you assume that this function can error. If you see a function that gets a context, I assume it's not forever blocking because I can always cancel out of it. Mm-hmm. But if what you do is you take a context and then you do dot without cancel on it, suddenly this function becomes blocking and it's uncancelable. So I would assume that some people might be tripped up by this. And if I were to use this proposal in my code base, I would just wrap it in a type def. Like if you do without cancel, you would get a different type. It's not a context, it's an uncancelable context. But that obviously lowers a lot of the flexibility of this proposal. It has been accepted. A bit more flexibility at the cost of perhaps future bugs.
I think the biggest problem, I think this is one that even Dave Cheney, I think, called out in the discussion, is it makes it easier to treat your context value as a bag of stuff, which is kind of an anti-pattern.
Calling the number one pattern you see in every HTTP server in the code base an anti-pattern is, sort of like how we managed to call what makes up most of the universe antimatter. It's the other way around.
Right.
There is, luckily, one proposal that's, at least in our opinion, just good. You want to tell us about loop vars?
Yeah, so I think we talked briefly about this. Was it last week? Yeah, some of the forward compatibility changes in the go.mod file that were accepted. And one of the reasons that the organizers wanted to add that capability was to make it easier to change the way loop variables are handled. Quick refresher, or if you're new, the basic idea is in a for loop, the variables are reused for each iteration, which has some surprising consequences if you're trying to use pointers to those variables or access them in a Go routine or something like that. So the proposal, the long-term proposal, is to change this in an upcoming version of Go, Go 1.21 will have this change enabled as an opt-in by setting the Go experiment environment variable to equal loop var. So the idea, this isn't ready for prime time. It's an experimental feature, but it's being added to Go 1.21 so that you can start experimenting with it on your code if you want to. If you're frustrated by these loop variables, you can compile your code with this experimental feature and see how it works.
So let's talk about conferences. Any conferences that happened or coming up?
Well, why don't you tell us? I think you were at one of the main conferences that happened in the last week.
Yeah, so actually last week I spoke at GopherCon Israel. There were a ton of really good talks. Specifically, Derek Parker, if you don't know him, he's the person who wrote Delve, had a really interesting and unexpected talk. I sort of expected going in that he's going to talk about, okay, this is Delve, this is how you debug, this is very low-level stuff. But he actually went in a very unexpected direction into Go is the language of dreamers, and dreamers want to be innovators, and Go enables innovators to be builders, and sort of how Go's features and community and sort of mindset really allows people to do a lot of interesting things. It was a really passionate talk, and he was the keynote speaker at the conference, and I really understand why. Amit Lichtenberg, she gave a really good talk about generics. Natalie Pistanovich, she gave a great talk about AI-assisted Go, which is up on her GitHub. So I just recommend you go check out the slides. Some really interesting points there. Liri Sokol gave a really funny, meme-filled and interesting talk about virtual file systems, which I really liked. Aviv Komisar, he gave a great talk about hot path optimizations. It was just really, really, really informative. I took about half of what I learned directly into the Go team at work. So the moment the recordings go out, I recommend you check them out. And also, one of my colleagues and I gave a talk.
Very cool.
Overall, it was a great event, and I can't wait for next year's GopherCon.
Rounding out the news for this week, Apache Arrow 11.0 was released about a week and a half ago, which isn't Go specific, but they have Go support that has been growing in maturity. And I think it's worth mentioning because we're going to interview the maintainer and developer of the Go support for Apache Arrow in the second half of the show. So if you're interested in sticking around past the news, stick around and learn what Arrow is. It's a pretty cool project.
With a pretty cool maintainer, if I might add.
Indeed.
Now is a good place to mention our sponsor, Undefined. Nil pointer error. We don't have a sponsor yet. We're looking actively for sponsors. If you want to reach out, please do. And this is a good opportunity to say how you can reach out to us.
Yeah, find us, of course, at cupago.dev. That's our website. You can email us at news@cupago.dev. You can find us on Slack, on the Gopher Slack, at the Cup-O-Go with Kebab Case channel. You can occasionally find us at GopherCons and other places and physical events.
If you like the show, please come talk to us at the Gopher Slack. We really appreciate your feedback. One interesting programming note is that we listen to your feedback, and some people like only the news, some people like only the interviews, some people like both. So we're experimenting with some different ideas on how to lay out the podcast. We're thinking about either keeping it right now as it is, 2 sections of the same show, perhaps 2 different episodes in the same show, or perhaps even 2 different shows, just the news and just the interviews. So we're going to be discussing that on Slack. We're going to be posting up a survey. So if you have an opinion, and it's less controversial than whether you think telemetry should be added to the Go toolchain or not, please hop over to the Cup-O-Go Slack channel where we're going to be posting the survey.
Yes.
And if you want to engage with us further and support us, please leave a review and a rating on Spotify, iTunes, or wherever you listen to your podcast. It really helps out a lot.
Hey, we're back, and I'm excited to be here with Matt Topol, who is a contributor to the Apache Arrow project, which, as you heard from the earlier part of the program, recently released a new version. So, Matt, welcome to the show. Would you tell us a little bit about who you are and what you do for Arrow, and then we'll talk about the project.
Great to be here. As mentioned, Matt Topol. I currently work for Voltron Data, and I primarily just work on the Apache Arrow libraries in general. That's my day-to-day job now. I joined Voltron Data last year, in part because I wrote the first and currently still the only book on Apache Arrow, in-memory analytics with Apache Arrow. You can get it on Amazon, you can get it on Apac, etc. But I've been working with Go for quite a while, and I primarily work on the Go implementation for Arrow. And at this point, I'd say huge swaths of the Go implementation have been implemented by me, along with the official Arrow Parquet implementation.
Nice.
You mentioned you're currently working for Voltron Data, which obviously has Apache Arrow smeared all over the homepage and all over the labs. Just in a high level, before we dive into the technical details of what you do in the open source library, what is it used for? It says, at least in Voltron Data, y'all use it for data analytics ecosystem. So
Voltron Data is startup, and right now the main product it does provide is a Arrow Help subscription and enterprise subscription with Arrow development, while things are being developed for actual product to sell beyond that, but I can't talk about that. But Arrow is heavily used for any sort of data analytics, data pipelines, data transport, if you're passing data back and forth between different processes or different services or et cetera. Because Arrow defines an in-memory format that is going to be the same no matter which programming language you're in, you're able to pass the data and stream the data even between systems or processes or what have you, without paying a serialization or deserialization cost. The bytes in memory are the same bytes you send across the wire, which are then just the bytes in memory at the end of the system anyways, with a small metadata on top to explain how to interpret it.
I bet that would scare a lot of our listeners who might be like, why is it not putting it in JSON and then base 64ing it? I thought that was what we were supposed to do for data.
And the problem with that is the fact that if you have the data in JSON, and then you want to actually perform computations or analytics on the data, you then have to convert the data from the JSON into something you can work with.
Yeah.
Whereas the in-memory Arrow format is a in-memory format designed to be efficient for computation and analytics. So you don't have to pay that serialization, deserialization cost of going from data in your main memory, and then you pull it out of the main memory, put it in the cache so you can decode it, and then you have to drop that back into main memory again, and then pull it back in when you use what you need. You don't have to do any of that, because that's what you have to do in those systems. But with Arrow, you can just operate on it as is where it is. It's designed to give you, an O of 1 access, random access into the arrays. It's tabular but column oriented, with schemas in a very, very well designed type system. And you can stream it in what's called record batches, which are basically just a collection of columns and a schema and some metadata. And so a stream of Arrow data is just a stream of record batches, which makes it really, really nice for passing data across the wire. Arrow defines a IPC format for streaming data.
It also has a MIME type, right? So it's supported.
It has its own MIME type, yeah. Mm-hmm. Arrow has its own MIME type. It was created in 2016, was when Arrow was first developed, and was kind of there to kind of fit a niche where they saw that about 80 or 90% of CPU time was being in a complex system. At the time, Hadoop was the biggest thing. Mm-hmm. You're looking at Hadoop, and you're going to different databases. 80-90% of that CPU time is being spent on serializing and deserializing that data every time it goes from one system to the next, because everything has their own internal representation of the data.
Yeah, 80 to 90% of dev time also. Wait, is this time it's serialize, marshal, encode? Which one am I looking for?
Exactly.
But it's all the same, just shuffling the same bits around.
Exactly. And then for Arrow, you can get the benefits of not having to do that. You get zero copy where it's able to.
So help me understand why. I mean, I get the benefit, especially at the network layer, but it kind of I'm imagining that this in-memory format kind of just pushes that serialization, deserialization to the point of memory access. I mean, I can't imagine that this format that you're using is as close to the native format as is ideal for every language. Maybe it is for some and less for others. So isn't there some sort of tax that you're paying at that point? So I found a piece of data in memory. Now I need to put it in some format that I can display it on the screen, or I can do whatever I'm going to do with it, right?
At its core, data is, in whatever language it is, data is bytes, right?
Right.
And so if you have a column of 32-bit integers,
sure.
If I tell it I want the value 5 in that column, I know I can go to 4 times 5, go 20 bytes from the start of the buffer.
Right.
And the next 4 bytes is the integer I want.
And that's the same in Go, C, Rust, and whatever.
Exactly.
How do you address the difference between big endian and little endian systems?
Good point. And Arrow, in the schema for an Arrow record batch, it has a spot where you can specify if the data buffers are big endian or little endian.
Okay.
Now, if you're just passing the data through, if it's just being passed through a system, like you say you have a service, and you're going to request some Arrow data, maybe using Arrow Flight's protocol, and you're going to get a stream of Arrow data. If the data is just passing through your service and you don't have to interpret it or actually use it, then you don't care about the endianness because you're just passing the raw bytes through and you're fine.
Right.
If you do care about the endianness, the schema has a flag that says what endian the data for that field what data is, and not all of the implementations yet support it, but most of the implementations do support doing a conversion if you need it.
Okay.
So if you're currently running on a big endian system and the data came or was created in a little endian system, it would, the Go implementation does, and so does the C++ implementation, will on the fly convert when you read in the data if you need to from the big endian and little endian systems if you need to do that. Like I said, if you're just passing the data through, you don't need to do the conversion.
It's just opaque bytes at that point, right?
Even if you're not using it as opaque bytes.
Okay.
The API provides an option to say do or don't auto-convert.
Oh, nice.
Because maybe you want to still read the schema, but you're not going to actually use the data bytes in the system. And you want to you're going to pass data, you're going to pass the whole thing through, but you want to do something with the schema. You don't have to pay the cost to do the conversion between endianness if you don't want to. And that's kind of the guiding light in a lot of Arrow's APIs, is to try to, wherever possible, allow consumers to get a zero-copy communication. One of the things Arrow defines is a C data API, where you can take the Arrow data buffers and share them across a C API between languages and implementations.
And then bind to that C binary from different languages, you mean?
Exactly.
Awesome.
Because it's just a C interface defined in a header file, and all it consists of is a little bit of metadata. What is the type? What is the length of your data? How many buffers? Then just a couple void star pointers to the actual raw data buffers. And then you're just passing the pointer across the C boundary. And then the language receiving it knows how to interpret what the raw bytes are based on that metadata saying, oh, it's this data type. There's this many buffers, et cetera, et cetera. And so you can export and import data between processes or within a process across different systems without having to pay to copy the actual full data. For a great example of that is DuckDB takes advantage of that. DuckDB provides a Arrow interface that uses that C data API to avoid having to copy. If you're in Python and you're using pandas, one of the co-creators of Arrow is actually Wes McKinney, who created pandas. And the Python API provides the ability to, where possible, do a zero copy from a pandas data frame to Arrow tables. And then you can pass that across or whatever systems you want to do.
Sounds like there are 5 people who are very passionate about data in memory, are holding all the world's bytes in order.
Well, I mean, one of the biggest things is trying to get, if everybody is talking Arrow in their internal representation, which is efficient, then everything gets to be able to interchange and intercommunicate and interoperate really easily. And whether you're building services in Go, or if you're building, or what I'm trying to get across, I'm trying to help build out, is Go doesn't really have a standardized data frame thing. Mm-hmm. I want Arrow to be that, or at least be part of that. And that's one of the things I'm trying to promote with Arrow, with the Go implementation, is to do that. It's extremely high performance. It's an Apache open source project, so anyone can contribute. Please contribute. There's a corresponding Parquet Go library in the Arrow repo, which has an integration with the Arrow library, so that you can automatically and easily go from reading a Parquet file right into Arrow formatted arrays and buffers and memory, and then write Arrow tables right to a Parquet file.
That already connects to, I think, a lot of people's workflows.
Exactly.
Like if you have a data engineer in your company already and they do Java, they probably store Java or Scala or whatever to do data processing. Often they'll use, even if they're not aware, Apache systems that behind the scenes, and then use up Parquet and Arrow.
Yeah, exactly. And a lot of systems like, say, Dremio's data lake processing system, the internal representation it uses is Arrow. The whole thing's written in Java and drops to C++ when it needs to, but it's all using Arrow. And they actually helped develop Arrow's network protocol, Arrow Flight, and Arrow Flight SQL, which are protocols around passing streams of Arrow record batches, which means you can get very, very high memory performance services to process and operate on data. At my previous company, I ended up writing a service that essentially was a custom designed GraphQL evaluator in Go, but instead of using JSON, I used Arrow as the internal representation for everything and generated SQL queries. And I was passing, gigabytes of data through the system to answer requests, but the service never went above 100 megabytes memory usage.
That was a talk you gave at the Subsurface, right?
I gave a talk at Subsurface about it. Yep, exactly. But I also recently gave a talk specifically on using Arrow and Go with Parquet and CSVs at ApacheCon last October. Mm-hmm. And that one you can find on YouTube. That talk is explicitly all about and tutorializing getting started with using Arrow as kind of your way of using data pipelines. You can build a full data workflow pipeline entirely in Go, because channels are great for passing Arrow record batches, because it's just pointers.
Yeah. In the end, it's all just pointers and bytes.
Exactly.
That's a very nice way to think about computers and software.
Yeah. I mean, the entire benefit and the big point here is that you want to reduce the amount of copying when you're working with data. When you have large amounts of data, you're often going to spend a ton of time on the CPU cycles, a ton of memory on just how many times the data itself gets copied. If you can reduce those copies, systems become more efficient. And that's kind of where Arrow fits in there. Reducing those copies internally and externally between systems.
And let me ask you something here. I obviously agree technically that, reducing copies will make systems more efficient. But sometimes, as a developer or as an engineering manager, especially people who are working with Go, sometimes choose Go because of the developer ergonomics, right? Mm-hmm. It's a very simple language. You can learn it really quickly. The learning curve is is not too steep. Mm-hmm. How would you rate Arrow, Go Arrow and Flight SQL and the rest of the sub projects around this area from scary to friendly? Mm-hmm.
I would say that overall at the top level, they're very friendly, but there are still rough edges that can be kind of scary on certain things, because it's still in the domain of software. it's still a relatively young project. You know, it's heavily in the community developed. So and we're seeing more interest in the Go implementation now. And it's starting to pick up more. For example, Google BigQuery's example tutorial in Go uses the Go Arrow library for requesting data from BigQuery. OpenTelemetry has a PR that they're working on to use Arrow as their format for OpenTelemetry, passing data back and forth for their messages. So Arrow is in general friendly, but there are still rough edges. And there's pieces of it that could definitely be improved in some of their friendliness. And there's lots of room for improvement on the documentation. But I'm trying.
And here's a call to action to our listeners. If what Matt is talking about sounds interesting to you and you're looking for some open source, if you visit Matt's GitHub, you can see his all his squares are very green. If you want your GitHub to look like that, sounds like here's a project with an active, extremely passionate maintainer who's just looking for people to help him out.
The Arrow repo is a mono repo. So the implementations for C++, Go, Python, Java, they're all in the same repo here.
Mm-hmm.
And releases are tagged appropriately so you can get the right Go tags and the right Go versioning. But there's a mailing list, user at arrow.apache.org, dev at arrow.apache.org, and the mailing lists are very active. So even if you're not quite yet ready to dive into the code, check out the mailing list, check out the website, arrow.apache.org, like the documentation there. Packagego.dev. I've done a lot of work to make sure the Arrow docs on packagego.dev looks good, because before, a couple of years ago even, it was terrible. So there's lots of room for improvement, but it's a lot friendlier now than it was. And I guess that kind of segues us good into the actual Arrow v11 release.
Let's talk about that. What is new in release 11, and especially as it relates to Go, since that's our audience?
Aside from general bug fixes and some other memory things that were fixed in here, one of the big things that goes out with the v11 release for Go for Arrow is a basic compute package for Arrow arrays. You can take your Arrow data that's coming from, you have columns of data or tables or record batches, whatever, without having to copy, just on the data itself, you can add, subtract, multiply, standard scalar, binary, and unary arithmetic across columns of data. That's been highly optimized, where if it's available, it'll use SIMD.
Oh.
If it's not available, it drops to pure Go, no SIMD. Mm-hmm. And it'll work whether you're working on a 64-bit system, 32-bit system, ARM, x86, works in all of them. You got some really useful compute functions that are now available right in the Arrow library.
On tabular Arrow data?
Yep.
So sounds like the actual beginning of the Go pandas thing, right?
The Go Arrow library has the C data implementation exists. So you could, in fact, actually, there's an example in my book that takes data read from a pandas data frame and uses Arrow and passes it to a Go shared library.
The same memory.
Same memory.
Wow.
No copying.
So I'm just voting, Python P pandas. How about Go, you call the library giraffes?
Hey, why not? But yeah, it's like there's a direct example in my book, and there's a GitHub repo that goes with the book, has all the code samples that, has the Go examples for everything, but also, like I said, you've got a Python mod, you got an example Python extension through the Go API.
Matt, I have to say, one thing that's really standing out to me, you wrote a book. You wrote the book about this. You're talking about this subject extremely passionately, and you've been around it for a while. How comes you're so passionate about, at least to me, it looks like a very specific subject?
In my previous job before I joined Voltron Data, I worked a lot on distributed systems and distributed data systems. And one of the biggest things nowadays when you're dealing with large amounts of data is how do you efficiently get these systems to talk to each other, especially when you have very, very old, because I worked at a financial data service company, you have these very old systems that just aren't using modern technologies. And we're seeing more and more modern data stack. You've got Parquet, you've got Iceberg, you've got Delta Lake, you've got all these different systems. Arrow is a glue. Arrow makes it really efficient and easy to do this. And I started using it at my old company because it solved the problem I had.
You felt the pain.
I went to the Hadoop conference years ago, and I started shoehorning Arrow into a solution because it sped up the solution by over 100 times.
Wow!
Wow!
And that was just because it was going from a custom built proprietary in-memory format to just using Arrow the whole way through. So I'm passionate about it because I'm passionate about cool stuff. I find the technology interesting. That's really what it is. I find it really interesting. I find what it's trying to do, and I find the implementations very interesting. The actual code itself it's interesting to see how the problems are solved. And so I'm passionate about it because I find it cool. I find it interesting.
Nice. One question we like to ask all of our guests, Matt. We'll put you on the spot a little bit here. You're a Go. You're not only passionate about Arrow, you're also passionate about Go, as I've picked up. If you could take one thing out of Go, what would it be?
If I could take one thing out of Go,
or if you had to take something out of Go, some feature, gun to your head, something has to go. What is it?
That is a tough one. So one thing that actually has tripped me up a little bit while developing the Arrow libraries is the fact that the plain int type will change whether it's 32-bit or 64-bit based on what your underlying architecture is.
Mm-hmm.
And so you have to handle that when you're handling the Arrow development because I can't just say use an int here.
Okay.
I have to say, okay, use int32, use int64.
You would take out the int keyword type in Go, break 50% of the lines.
Yep. Oh, this is a tough question.
Well, there's a tougher part 2 coming up.
Uh-oh.
Part B is the other way around.
That one's actually easier for me to answer.
Yeah? What would you add to Go if you could?
So with the generics that just came out, one thing that I've found that I would love to see added is something similar to C++'s template of a constant type, where you could do a generic on a value type, like an integer, not on the type, but on the actual value.
Oh.
So you could have a generic function that I could pass in, say, a constant value as the generic type, and then use that for constructing buffers or with a constant, or more to the point, being able to get the actual size of a data type as a constant, but generically.
So we need to put you and Mikita back on the same call at some point, because when we asked him what he would remove, without a second thought, he went generics. And you want to add C++ templating.
I don't want to go full. I don't want to go full template. No. I don't want to go full template. C++ templates are way overcomplicated. I've used them. I enjoy them sometimes, but they are way overly complex and not something I want to see whole hog put into Go at all. But generics definitely have improved code duplication, or rather reduced code duplication sufficiently for me that generics are not something I would want to see removed.
All right. Well, Matt and your cat.
Yep, Logan says hi.
Thanks a lot for joining us today.
Before we let you go, Matt, if people are interested in following you, are you available on social media or anything?
I'm on Twitter, I'm on LinkedIn, I'm on Mastodon.
We will have links to those in the show notes if you're interested in following.
Well, thanks a lot, Matt.
Thank you too, guys. Take care.
right, so Matt has dropped off the call. Such a great guy. We just talked to him for another 20 minutes.
Yeah.
I wish we would record that as well. Really insightful stuff about how he got into the project and whatever. So first of all, let's mention his book again, In-Memory Analytics with Apache Arrow. Perform fast and efficient data analytics on both flat and hierarchical structured data. That's a catchy name.
Say that 5 times fast.
I could read that and write that 5 times fast with Apache Arrow, but if you want to be able to do that as well, you can grab the book in Kindle and in paper, in Dead Tree format, if you're into that. Also, Matt mentioned that he's going to speak at a virtual conference on March 1st, and he's going to be talking about Arrow-related stuff, obviously, at Subsurface on March 1st. So if you're listening before, it's a virtual con. If what Matt talked about was interesting and you want a more in-depth dive into the subject, go check out Matt at Subsurface.
Not only is it virtual, it's free, as I understand. So double bonus there.
Yeah, 100%.